All right, honorable Math 1 students, I am sure that you've already got the coordinates of this point up in the top right. You're that savvy. You know this distance on the bottom was A, and for a parallelogram, this has also got to be A. The top piece has to be A. You also know that the distance here between the y-axis and that point is B. So B plus A should get you over here to that point. And this vertical distance, no matter where you go along here, has to be C. So that last point should be A plus B comma C. Hey, punk kids, keep it down over there. Got my kids and my dogs fighting. I don't know who's going to win. Next one, over here in quadrant 1. Which one's quadrant 1? Anybody know which one's quadrant 1? Daniel? Yes, quadrant 1 is the one on the right, top right. Well done. So over in quadrant 1, I want you to put a little triangle up there. Make that an isosceles triangle. Make it isosceles. We love that word isosceles. We're going to use it a few times. In class, I would usually ask, which one of these coordinates can you now get? And you probably know the x-coordinate is 0. So we're going to call that first one b comma 0. Sorry, 0 comma b. I got myself backwards here. X is 0. We're up b units. In class, I'd often ask, can anybody give me the coordinates of that top point now in terms of b? And hopefully you try and you try and try. Wait, nah. This distance here has nothing to do with how wide the base is in this triangle. So I'm going to introduce a totally new coordinate. I'm going to call that C. I could get this coordinate in terms of this distance and that distance, but I didn't do that. I said this was B and that's C. Then I typically in class pause and I say, what can you tell me about that point? Can you tell me the X or the Y or both? And if you understand symmetry, you can try this on your own. If you understand symmetry, this line of symmetry that goes this direction across has to hit the midpoint right here. This is now relating the midpoint formula to what we're doing. The midpoint here would be 0, comma, and it would have to relate to B and C. So most people can figure this out. The X coordinate here has nothing to do with A and B, sorry, with B and C, so I just call that A, comma something. Some people think, well, maybe you add B and C together or subtract them, you can get that point. Close. If I add them together and divide by 2, in other words, I find the midpoint of these two, that's telling me the y coordinate. So the sum of A and B and C divided by 2 will give me the y coordinate of that missing point. All right, we'll go to the next one here. Hopefully that makes sense, give you a chance to digest that. What kind of figure does that appear to be? And again, I've stuck the bottom left corner at the origin. And usually somebody in class can quickly identify that that is, in fact, a trapezoid. Trapezoids, the top and bottom are parallel. The other two are not parallel. There's a blank there to describe what type of trapezoid it is. We'll come back to that in a minute. I'm going to start off like I did the other ones. I typically give you one of the coordinates, just because we're going to throw it on a coordinate plane, we're going to define it in terms of variables, not numbers, so it works for any case of trapezoids. So we're calling that point A, comma 0. And then I'm going to go up to the top right and give you some information about that point. I can use A to describe that point. That point is A plus B, comma C. So the challenge or the question is, can you tell the coordinates of this one if this is an isosceles trapezoid? That's the word that's missing here, an isosceles trapezoid. So pause this thing, see if you can get the top left point. Now, understand symmetry a little bit. If you were to draw a vertical line here, it would look exactly like that one. It would tell you a lot about the point there. If this is flat, the y-coordinate here is still C. And if you draw this little line here in altitude and sort of think of it like that, this distance is A. And then from that vertical line to over here has got to be B. So if that distance from my finger width there, or the marker width here is B, going the other direction, it's got to be negative B. So that missing point we're looking for is negative B, comma C. Hopefully that makes some sense. It's just using this vertical distance that cuts A out of there. That distance has to be B. We're going the other direction now. We're in the negative quadrant, though. All right, example 4, beautiful circle there. These little yellow points you can kind of see on the screen here are called points of tangency. Points of tangency means something just barely touches. So if I were to balance the marker on my finger here, the marker's circular, and where it's just touching and balancing my finger, that's called a point of tangency. And actually my finger is called a tangent line, which means a line that just touches a circle or just touches some curve. A parabola could be tangent to as well. Big calculus term when you get to calculus. So I'm going to give you some information, numerical this time, and ask you to find A and B. So I'm going to give you that bottom point. That's a point of tangency just touching the x-axis is 6 comma nothing. And I want you to see if you can find the coordinates of A comma B over here on the right. And that is the point that is the furthest to the right in that circle. I'll be back in part 3 to see if you've figured that out, and I hope you have.